Welcome to clickmyprojects.com. Here we discuss about histogram matching, attack on selective perceptual video encryption in H264/ABC. In cryptography, encryption is the process of encoding messages in such a way that eavesdroppers or hackers cannot read it, but that authorized parties can. In an encryption scheme, the message or information is encrypted using an encryption algorithm, turning it into an unreadable ciphertext. This is usually done with the use of an encryption key, which specifies how the message is to be encoded. Any adversary that can see the ciphertext should not be able to determine anything about the original message. An authorized party, however, is able to decode the ciphertext using decryption algorithm that usually requires a secret decryption key that adversaries do not have access to. For technical reasons, an encryption scheme usually needs a key generation algorithm to randomly produce keys. There are two basic types of encryption schemes. 1. Symmetric key and public key encryption. Context adaptive variable length coding is a formation of entropy coding using it in H264/MPEG-4 ABC video encoding. It is an inherently lossless compression technique like almost all entropy coders. In H264/MPEG-4 ABC, it is used to encode residual zigzag order block of transform coefficients. It is an alternative to context-based adaptive binary architecture coding. CAVLC requires considerably less processing to decode than CABAC, although it does not compress the data quite as effectively. CAVLC is supported in all H256 profiles, unlike CABAC, which is not supported in baseline and intended profiles. CAVLC is used to encode residuals zigzag order 4x4 blocks of transform coefficients. CALVAC is designed to take advantages of several characteristics of quantized 4x4 blocks. Conventional cryptographic algorithms, which generally aim to encrypt text data, however, are not well suited for video encryption. This is due to the fact that conventional encryption algorithm cannot process the large volume of video data in real time. Moreover, it is almost impossible to adapt them to special video application paradigms which pose special requirements that are never encountered when encrypting text data. Video compression removes redundancy, making it hard to guess information about one part of the compressed bit streams from another. Also, compression algorithm often exhibits concentration, a high dependency of reconstruction quality on some parts of the compression syntax than on others. Combining these properties suggests selective encryption. The idea that compressed bit streams can be adequately secured from eavesdroppers with only part of the bit stream encrypted. Reducing the fraction encrypted can help to reduce the total complexity of implementation, which leads to reduced encryption and decryption time. Selective encryption can be suggested for a number of specific real-time applications. Slices in a picture are compressed by H264/ABC using the CALVAC method. Here, in our proposed methods, we are using video encryption by using the histogram differences of the frames. Here we use CALVAC method to encrypt video and by using standard AES algorithm. Here the encryption was done by histogram matching of each and every frames in the given video. This is the flow diagram of our project. In the first step, we initialize the given video. In the initialization stage, we estimate the size of the frames and convert this into record sizes. Then from that, we convert the videos into frames. In this frame conversion stage, we convert the frames into an image file format and stored in a separate folder. These frames are used in the further encryption process. In the encryption stage, we encrypt the given video by using CAVAC method. After the encryption stage, we check whether the frame is I format or pre format. If the frame is in I format, then we estimate the histogram value of that frame. If it is in P format, then this was directly given to histogram matching stage. In the histogram matching stage, we use the P and I and matching these frames by using histogram value H. This iteration was running for all the frames in the given video. Then finally the matched frames are extracted and converted these frames into bit streams and made them to transmit. Thus we encrypt the given video by using CVLC, and encrypted frames are converted into bit streams and made them to transmit. Now I am going to explain the running process of our project. Now run main.m file. Here it gets the input from you. Select any one video to encrypt the video. The figure here displays the inserted video. This video is made as an encryption. In this stage, it converts the frames into an image. Then it gives the memory allocation for each and every frames. The frame indexes gives the frame numbers, and the byte information gives the file sizes of the each and every frame. Here this gives the encryption of each and every frames. Here this is done by using CAVLC. The output reconstructed image gives the encrypted image. This done for each and every frames for the given video. Finally, this encrypted video is converted into an bit streams, and finally this was sent to transmission. This was by using AEC. Here the matrix gives the initialization of AEC coding. And finally, the encrypted output was displayed in the command window. Here this gives the converted into bit stream for each and every frames. Then the video frames are converted into bit streams. Finally, we compute the PS0 value for each and every frames between the original frames and encrypted frame. Thus we encrypt the video by using CAVLC with the histogram of frame, which gives histogram matching attack on Selective Perceptual video encryption in H264 AVC. Thank you.